In this next video, we're going to take a look at another type of quadrilateral, which is called a kite. A kite is symbolized by two pairs of equal sides in length. Here is a picture of a type of kite that we're going to look at. As you can see, we have two pairs of equal sides in length. We have two diagonal measures as 3 centimeters and 3 centimeters, and we have two other diagonal measures as 5 centimeters and 5 centimeters. Again, pay attention to the solid figure. The solid outline is represented by our kite. And don't worry about the dashed lines for a second here. If you split the left side of our kite and our right side of our kite, you'll get two equal triangles looking as follows. Since we know how to calculate the area of a triangle, we can do that. And we're going to do that in our next slide. As you recall, the area of any type of triangle is just 1/2 times base times height. Well, what is our base? What happens if we just rotate our figure as follows? Now we can calculate our base. Our base is just 7 centimeters. What is our height? Our height is 2 centimeters. So we'll multiply 1/2 times 7 centimeters times 2 centimeters, and that'll give us the area of just one triangle. And 1/2 times 7 centimeters times 2 centimeters gives us 7 centimeters squared, and that's the area of one triangle. Well, to find the area of the two triangles, we just multiply our 7 centimeters squared by 2. And 2 times 7 centimeters squared is 14 centimeters squared. And keep in mind that 14 centimeters squared is the area of both triangles, which, remember, both triangles are represented by that whole kite. So the area of our kite is just 14 centimeters squared. As a closing statement on the area of kites, notice that the area of a kite is just 2 times 1/2 times your base times your height. And if you take a look, notice that 2 times 1/2 gives you 1. So your area of a kite is just going to be base times height. Another type of quadrilateral we'll look at is called a trapezoid. A trapezoid is signified by two 90-degree angles, and it also has one pair of parallel sides. Here is our basic trapezoid. As you can see, we have two 90-degree angles on the top left and the bottom left corner of our trapezoid. Take a notice of something. What happens if we duplicate this trapezoid as follows? Now we'll just rotate it. As you can see, after I rotated it, doesn't that just look like a rectangle? We know the area of our rectangle. Area of a rectangle is just base times height. The area of our rectangle is going to be base times height. Well, what's our base? Our base is just going to be 8 centimeters plus 5 centimeters. And we're going to multiply that by 3 centimeters because 3 centimeters is our height. We need to take 8 centimeters plus 5 centimeters first. 8 centimeters plus 5 centimeters gives us 13 centimeters, and we multiply 13 centimeters by 3 centimeters. And 13 centimeters times 3 centimeters gives us 39 centimeters squared. And that's the area of the rectangle. However, didn't we just copy that trapezoid and rotate it to make a rectangle? So we're going to take half of 39 centimeters squared to give us the area of the trapezoid. 1/2 times 39 centimeters squared gives us 19.5 centimeters squared. 19.5 centimeters squared represents the area of that trapezoid. However, instead of having to create a rectangle, we're going to create something on the next slide to show you the area of the trapezoid in an easier manner. We're concluding that the area of a trapezoid is just going to be 1/2 times your lower base plus your higher base times your height. And at the bottom, you can see that's exactly what we did in our last slide. We have 1/2 times 8 centimeters plus 5 centimeters times 3 centimeters. Notice that after we evaluate that whole expression, we get 19.5 centimeters squared. And again, that's just the area of our trapezoid. The next type of quadrilateral we'll look at is called an isosceles trapezoid. An isosceles trapezoid has two sides of equal length. I'm sure this is the type of trapezoid you're most familiar with. Here is the picture of the type of trapezoid we'll look at. Just as we did in our last type of trapezoid, we're going to duplicate this trapezoid and rotate it as follows. Doesn't this just look like a parallelogram? Remember, the area of a parallelogram is just base times height. What's our base in this case? Our base is going to be 7 centimeters plus 3 centimeters. We're going to evaluate 7 centimeters plus 3 centimeters, and we're going to multiply that by our height. Well, what's our height? Our height is going to be 3 centimeters. So this becomes 10 centimeters times 3 centimeters. 10 centimeters times 3 centimeters gives us 30 centimeters squared, which is the area of our parallelogram. Remember, the area of the parallelogram is going to be twice that area of the trapezoid. We need to figure out the area of the trapezoid. Remember, the area of the trapezoid is just going to be half the area of our parallelogram. And 1/2 times 30 centimeters squared will give us 15 centimeters squared, which represents the area of the isosceles trapezoid.
I didn't say plus.
As a closing statement on the area of an isosceles trapezoid, the area of an isosceles trapezoid is going to be 1/2 times your lower base, which is 7 centimeters, plus your higher base, which is 3 centimeters, and we'll multiply that by our height. Remember, the height is going to be the vertical line segment that meets your base at a 90-degree angle. Our height in this case is 3 centimeters. And notice that the area of our trapezoid is just 15 centimeters squared. A final type of quadrilateral we'll look at is called a rhombus. A rhombus has all sides of equal length and opposite angles are equal. Here is the rhombus that we'll be looking at. As you can see, all sides are 5 centimeters in length. And we won't worry about the angle measures in this case. Here's what we're going to do. Take a look at the dotted figure there. Notice that if we cut that in half, we'll have 2 equal triangles. And we'll show the triangles in a second here. Again, notice that the triangles are equal in length. And we know how to calculate the area of any type of triangle. The area of any type of triangle is just 1/2 times base times height. Notice that I rotated both of our triangles so that they are facing the same direction. And our base in this case is just 8 centimeters, and our height is 3 centimeters. And 1/2 times 8 centimeters times 3 centimeters gives us 12 centimeters squared, which is the area of one of the triangles. We need the area of both triangles because we want the area of the whole rhombus. So we just multiply 12 centimeters squared by 2 because that will give us the area of both triangles. And 2 times 12 centimeters squared gives us 24 centimeters squared, which is the area of the rhombus. And notice that the area of the rhombus is just 2 times 1/2 times base times height. Well, notice that 2 times 1/2, doesn't that just give you 1? Since 2 times 1/2 gives you 1, notice that the area of your rhombus is just going to be base times height.